Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 1.2 entitled Exponents and Powers. And I'm going to skip over the first two problem of the day problems. Usually when I do these recordings, I'm not going to go over the problems of the day because they change from year to year. But I do want to take a look at example number 3. Example number 3 says to evaluate x times x times x when x is 4. So what we know from the previous section is that when they tell us the value of the variable, we can substitute that value in for all of the variables. So really, instead of x times x times x, it's 4 times 4 times 4. And then if you multiply all of those together, you can evaluate that to be 64. And then there's a question here that says, is there an easier way to write an algebraic expression like example number 3? So that means, is there an easier way to rewrite x times x times x? And the best way to rewrite that would be as x to the third power. And that uses an exponent, which we're going to talk about today. The reason that it's a 3 is because there are 3 x's. 1, 2, 3. So x is what we're multiplying by itself, so that becomes our base. And 3 is the number of times that we're multiplying it by itself, so that is our exponent. And that's what we're going to talk about today. So our objectives are to write an expression in exponential form, which is what we just did. We're going to evaluate the power. We're going to evaluate a variable expression when when the value of the exponent is given to us. And then we're going to find the volume of a shape. Now this first expression here, 3 to the 6th power, the whole expression as a whole is called a power. And that's the name for the whole mathematical expression with a base and an exponent. Now the base is the number that you are multiplying by itself. And usually that's the larger number in size. It doesn't have to be the larger number in value, but it's the larger number in size. And the exponent is the smaller number that's written as a superscript, and it's smaller in size, and it tells you how many times you're going to multiply the base by itself. So again, this whole expression is called the power. And usually we get a little lazy when we are speaking about exponents. Usually we call this whole expression an exponent instead of calling it a power. So sometimes exponent and power are interchangeable, but really the exponent refers to the small number in the superscript, and then the base is the number at the bottom. And what 3 to the 6th power really means is 3 multiplied by itself 6 times. So 3 times 3 times 3 times 3 times 3 times 3. And if you actually multiplied that all out, you would get 729. So exponents are a way for us to write large expressions in a more compact manner. And if you can see the definitions for power and base and exponent. And you do have an exponent key on your calculator. Sometimes they're a y to the x button, or sometimes they're like a little upside down V. That's called a caret key. So if you have your calculator, you can find that, and you can practice using it on your calculator in the next part of the notes here. And for the sake of time, I'm not going to fill in every single row or every single box in the rows. I'll just do the first 4. Okay. So using your calculator, you would want to type in 2 to the 1st power. And really, that should just give you 2. That just says you're multiplying 2 by itself one time, so it's just the number 2. 2 to the second power, that means you're doing 2 times 2, so that's 4. 2 to the third power is 2 times 2 times 2, so that's 8. And 2 to the fourth power is 2 times 2 times 2 times 2, so that's 16. And you just want to practice typing these into your calculator and making sure that you're getting those values as your answer. Your iPods or your iPhones will also have exponent options in there, so make sure that if you're using that, you know how to properly type in and evaluate exponents in there as well. And again, 3 to the first power is just 3. 2 squared should get you 9. 3 to the third is going to be 27. 3 to the fourth is 81. And just for the sake of time, I'm not going to do the rest. But I want you to notice that as I'm filling in these tables, and as you're typing these into your calculator and making sure that you get the same answers, you want to notice that there's a little bit of a pattern here. Anything to a power of 1 is just that number. It's just that base. Anything squared is that number times itself. And you'll notice that when you have bigger bases, your answer that you get after you evaluate it gets really big really fast. 5 to the fourth power is 625. So some more of those observations that we can make. It's basically that an exponent tells you how many times a number is a factor. So for example, 6 to the fourth is really 6 times 6 times 6 times 6. So this number, this base, is what you're multiplying. And the exponent is how many times you're multiplying it. So we've been saying that a lot now. Okay. And remember, a common mistake is that 6 to the fourth power, students often think of that as 6 times 4. That's not really what we're doing here. We are multiplying, but we're not multiplying the base by the exponent. We're multiplying the base by itself 4 times. Okay? So this is a big no-no. You can even put that in your notes and put a big cross through it like that, so you remember that that's an error in your thinking. Now there are certain ways that we want to read our powers. 5 to the first power is how we would read this. 5 to the first power. This one we can say 6 to the second, or we can also say 6 squared. This next one is 7 to the third power, or we could also say 7 cubed. This next one would just be 10 to the fourth power. So usually it's just the base and then to the whatever power you have. And this last one has 2 variables. And don't be fooled by that. It still follows the same rule. It's still 5 to the first, 6 to the second, 7 to the third, 10 to the fourth, x to the nth power. Now hopefully they would tell us what the values are for those variables, so then we could evaluate that expression some more and simplify it. But if not, that's how you would read it. Now remember, the examples that we do in our notes are going to be very similar to what you see in your textbook. So here we have to write the expression in exponential form. They're going to give you a little phrase, a written English phrase, and you just have to write the numerical exponential form for it. So here we have 8 squared, and when you see that, all you have to do is write 8 squared. 8 is the base, and 2 is the exponent. Y to the fourth power means that y is the base, and 4 is the exponent. 5 cubed, remember cubed is the shorthand way for saying to the third power. So 5 is the base and 3 is your exponent. And when you evaluate a power, you may need to substitute a value into the place of the variable before you simplify it. And we've been working a lot with substitution in the last section. So here, the directions will say to evaluate the expression when x equals 3 and n equals 4. So they're going to give us two different variables and two different values for them. So in part A, we have x to the third power, or x cubed. Now, the value for x is also 3, so don't be confused by that. I'm not making the base a 3 because of the exponent. I'm putting a 3 in for the x because the value of x is 3. Now, 3 to the third, or 3 cubed, means 3 times 3 times 3. So it's the base times itself 3 times. And that will give you a value of 27. So once we know the value of the variable, we can actually get a numerical answer. In part B, we have n squared, or n to the second power. So n has a value of 4, so that will be 4 squared. Remember, that is 4 times 4, and when you multiply that, you get 16. Now, some of you will be really good at looking at 4 squared and knowing right away that that is 16. So you may not need to do this intermediate step where you write it out. But if you need to do that, go ahead and do it. There's no shame in writing that out. Now, part C is a little trickier because we have two variables that we're going to substitute values in for. But it follows the same rules. X is 3 and n is 4. So now I have 3 to the fourth power. Now I have an actual expression with numbers that I can evaluate. So that's 3 times itself 4 times. 3 is my base, and 4 is my exponent. So it tells me I have to multiply 3 by itself 4 times. So 3 times 3 times 3 times 3 gives me a value of 81. And you could simplify that a little bit. You could do the first 3 times 3 is 9, and the other 3 times 3 is 9. So that you could think of that as 9 times 9, which is 81. So you can use mental math to simplify that. Now you're also going to see grouping symbols. And grouping symbols is just a fancy way to say parentheses or brackets. Sometimes you have the square brackets or you have the curvy, curly ones. But they tell you the order that a power has to be simplified. So when you're dealing with exponents and parentheses, you want to simplify what's inside the parentheses first. And if you have more than one set of parentheses, you start with the innermost ones. You start with the ones that are on the inside of the other parentheses. And you want to make sure you simplify any exponents as you go. So in your homework, these will look like example number 3 here. Again, they're telling us that x has a value of 3. So I'm going to do that first, just like we were. I'm going to substitute first. So I'm going to write my parentheses. And remember, this 2x is really 2 times x. So that's going to be 2 times 3 to the fourth power. Now the stuff inside my parentheses isn't completely simplified, so I'm going to simplify that first before I do my exponent. So 2 times 3 is 6 to the fourth power. And then when I do that, it's 6 times 6 times 6 times 6, which is 36 times 36, which is 1296. And you can use your calculator and the exponent key on your calculator to evaluate that. Okay, now this next one looks really, really similar. Part B looks very similar to Part A, except there's no parentheses. So what we want to notice here is whether or not we get the same answer. Are we going to get 1296 or are we going to get something else? And I'm going to give you a little clue. Parentheses matter. Whether or not you have parentheses in an expression can completely change your answer. So this here, since there are no parentheses, this is really like 2 times x to the fourth. That exponent is going to stay attached to whatever is directly in front of it. And the only thing that's directly in front of it is the x. So here, since we don't have the parentheses, it's not the 2 and the x that are being raised to the fourth power. It's just the x that's going to be raised to the fourth power. And again, my x has a value of 3, so 2 times 3 to the fourth power is what I'm evaluating now. So this is like 2 times 3 times 3 times 3 times 3. And if you want, you could do 3 to the fourth in your calculator, get an answer, and then multiply it by 2. Or you can multiply it all out like this. But you should get a final answer of 162. Very, very different from 1,296. And that's because of the parentheses. So you have to recognize that these expressions in example 3 are not the same. They have a very different meaning and a very different answer, all because of those parentheses. And we're going to notice that again here in example 4, where we have to evaluate our expression. Here we're going to be told that r has a value of 2 and s has a value of 3. So now we're just going to substitute 2 values in for the variables. And we got to watch for those parentheses. So in part A, I have r squared in parentheses, and r has a value of 2. So now I have 2 squared in the parentheses. And then I have s squared, and s has a value of 3. So now that's 3 squared. Now the terms in my parentheses aren't completely simplified, so I'm going to do 2 squared, which is 4, plus 3 squared, which is 9. And then I can add those together and get 13 as my value. Now part B is very, very similar, except now the r and the s are inside the parentheses and they're being subtracted. So here, I'm going to substitute 2 in for r minus the 3 in for the s. And then I'm going to square it. Now again, what's inside my parentheses has to be simplified first. So 2 minus 3 is going to be negative 1 squared. And I want to keep this in parentheses this time because of that negative. This really means that I'm taking negative 1 times negative 1. Okay, the whole negative stays inside the parentheses. The whole negative 1 is being squared. And that makes a big difference in our answer when we're squaring a negative number or a positive number, because a negative times a negative gives us a positive. So we get a positive 1 for our answer. Okay? So we're going to be reviewing a lot more with positive and negative numbers and refreshing our memories on the rules for multiplying and adding and subtracting and dividing with positive and negative numbers. So here remember, if it's a negative number inside the parentheses, that means you have to multiply that whole number with the negative by itself, however many times the exponent tells you. And our last example here deals with a little bit of a word problem, and it relates to volume. Now they like to talk about volume with exponents because when you deal with a volume, you're multiplying 3 things together. And if you have a cube is a cube because all of the sides are the same. So here's how you draw a cube. You've got 2 squares, and then you connect their corners. And a cube means that the length and the width and the height are all going to be the same. Okay? So we can simplify that as the side times the side times the side, or the side cubed. Now you might also know volume as length times width times height, but a cube has all of those values the same. So that's why we can abbreviate it as s cubed. Okay? So our last example says a box has the shape of a cube, just like the one I drew. Each side is 8.1 inches long. What is the volume of the cube? So if you want to draw another picture and label the sides, you can. It's not really necessary though, because we have our formula, volume equals s cubed. And they tell you in the problem that each side is 8.1 inches long. So they're telling you the value of s. S is going to be 8.1. That's okay that it's a decimal. Doesn't matter. We have calculators to help us figure this out. So I'm going to substitute the 8.1 in for the s. And I'm going to put it in parentheses here when I'm substituting, just so I know that that decimal stays together with the 8.1. You don't have to have it. You could still write it 8.1 to the third, just like that. Okay, these parentheses just show me everything that's being cubed. So now I would go to my calculator and I would type in 8.1 to the third. This means I'm taking 8.1 times 8.1 times 8.1. My length and my width and my height are all the same. And that's going to give me a final value of 531.441. If you didn't get that on your calculator, double check your work. And then I'm also going to do a label on here. It was inches. And remember, volume is always cubed. So 531.441 inches cubed. So that's the volume of the whole cube. And that wraps up our notes for section 1.2. There is your assignment to practice these concepts, and I will see you in class.